This is GScan-120 Pro Slide Scanner. This is the slide clip. It supports the standard size and the double size slides. Now I put this standard slide on this clip. After putting in the slide, we put the clip into the scanner. You can put it in any position of the rack as you want. Then close the door. Then we come to the monitor interface. After we put in the slide, the machine will automatically detect which position is the slide located in. You can see from this interface, this is the slide area of the machine. There are totally 4 racks with 15 positions each. You can totally put in 120 pieces standard slides and 60 pieces double size slides. Now the machine is under previewing. This is the thumbnail area. The machine will take a picture and it will be showed on the thumbnail. This is the real-time imaging area. It will show real-time field of view. Now you can see the preview is done. Then the slide is showed in purple. We choose this slide and click Brightfield Preview. And also you can choose Fluorescence Preview here. The machine is now doing Brightfield Preview. The mechanical arm inside the machine will place the tissue slide on the stage and will take a picture. The picture will then show in this thumbnail area. A small window prompts that the Brightfield scan has been completed. In the thumbnail area here, you can see a real-life picture of the tissue slide. And now I'll show you how the fluorescent preview works. Choose this slide, then click the fluorescent preview here. Using Brightfield Preview can effectively help us distinguish the effective scanning area and identify the level of the sample. The fluorescence scanning will proceed based on the Brightfield picture and will first be scanned by DAPI channel under a 2.5x magnification objective. It will also show a previewed fluorescent image under DAPI signal. You can see from the thumbnail area here, it is the process under fluorescence previewing. Here, from the image you can see, it's the fluorescence signal captured by the DAPI channel. The stronger DAPI signal, the clearer image will appear. It will be convenient for us to select the area and scan it later. Now the fluorescent preview is done. You can also directly click the Brightfield preview or fluorescence preview when you are going to scan slides in batches. It will automatically scan all the slides inside the rack. Okay, now we need to set up some parameters for fluorescence scanning. Here we need to create a new scanning parameter profile. First, select the scanning magnification. In this case, we will choose 20x objective lens. The scanning layer here, we choose single layer scanning. Below are fluorescence channel that our instruments have configured. Here, I select the DAPI and goldfish channel. After selecting the channel, we will look at the focus height and staining of the real-time image. Now the machine is running. The mechanical arm will clamp the slide to the staining stage for warp focus. Okay, the screen shows that our slide is already under the scanning stage. At this time, we need to move the red dot to the sample area. Then we click the DAPI button to see the fluorescence signal. At the beginning, we can increase the exposure and gain. Then adjust the focus height to find the best focus point. After that, decrease the exposure and gain to find the best image. Now we can see clear cell nuclei. Then we start to adjust the exposure and gain for another channel to make sure the image is not overexposed. After setting the focus height, we set up the scanning area. The size of the scanning area can be adjusted according to your needs. After selecting the area, we can mark some focus points like this. Then we click Save the setting. After that, we can start scanning. The instrument is now auto-focusing. It will perform a more precise focus according to the parameters we just set. The instrument will automatically find the focus position that is clearer than the human eyes. It will find the best focus height for each focus point we just selected. The red dot in the thumbnail area is the focus point we just selected. In this real-time image area, you can see that the image becomes clear from blurry. The instrument will generate a fitting focus surface based on the best focus plane and start scanning the whole tissue sample. You can see the scanning process here. The sample scanning has started. The scanner used the S-shaped array scanning method. It will scan all fluorescence channels in each field of view and then switch to the next field of view. After the scan is completed, it will splice into a complete image after algorithm shorting and real-time stitching. Here you can see the scanning track, which is S-shaped. In this real-time image area, you can see the field of view pictures under different channels in time. You can scan up to 9 fluorescent channels by our scanner. Now that all the pictures have been scanned, we can see more image details on the image viewer. This is the fusion image of the depth channel and the goldfish channel. Because we scan with a 20x objective lens, we can see a maximum magnification of 40 times on the softwares.